All right. So finishing up 1-6 today, we've done pretty much half of it. The operations with functions, addition, subtraction, multiplication, division. We have one more major operation to deal with. And then 1-7. I'm going to give you the review sheet for the chapter 1 test. It will also post in the announcements at 12 today. It'll be in the email with your YouTube link as well. You should be able to do practically everything except maybe the last question. And that's just to give you more time instead of just getting it next Monday and having to try to do everything before Wednesday. So you have until Wednesday, because that Wednesday we're going to review. We'll finish up anything we have left over on Monday in chapter 1, kind of type loose ends. If you want to ask some review questions after we finish up chapter 1, you can. But we're reviewing on Wednesday, and the test is Monday the 7th. Monday the 7th. That's what happened on Monday. I pushed it back because I expected to get through all of 1-6 yesterday, Monday before. Okay. Homework is due Monday the 7th. Okay. Please, I'm going to say this multiple times, but you have to turn in the assignment sheet as your cover sheet. You're in charge of grading and scoring your own homework with, with honor, integrity, blah, blah, blah. So all the directions are on the assignment sheet. At the bottom, it says section 1 through section 7. Give yourself a score, what you feel you deserve out of 10 points. Please, no decimals. If you think you deserve an 8.3, just give yourself a 9. I really wouldn't know the difference, but no decimals. You're not a figure skater in the Olympics. Okay? You have to add the total to the far right. You do not fill out the bottom. That's my job. Out of 20, I give you the final score. That is your cover sheet. It needs to be stapled to the homework. Stapled, not paper clip. Not put in a folder. I got to lug all of your homeworks home. It's not going to be stacked like this. And I know I said it to somebody a week, weeks ago. Hopefully you've been writing front and back, and we haven't. From now on, front and back, don't waste paper. It's going to be a stack like this. It will. Some of you are going to turn in all 7 sections. It's going to be on 2 pages. I've seen it. If I can't see it, I need a microscope, but I look through it. And that's what I do, is I look through how you graded your homework. Okay. I can tell when answers are just copied. So don't show up trying to put it all together. I do have a stapler, but don't show up and try to arrange it, put it all together, because we're waiting on you to start the test. I'm not going to start the test until I get all the homework. Until the end of class and finish your test. So if you're delaying everybody else starting the test because we're waiting on you to put your homework together, survival of the fittest. Show up, have it all done. Don't wait until Sunday, October 6th to do your homework. The reason why I give you until the day of the test is because I know you guys have other classes, you have other your jobs, you have families, you got to take care of those other things. You're not going to always be able to get to the homework right away. And I don't want to set you up for failure. But I know setting up for failure means that I give you so much time, you're just not going to do it. Well, that's where you and responsibility comes in. Because it's 18% of your overall grade. When you think about it, and it's all on you because you even get to grade your own homework. It's not about getting it right or wrong. It's actually about doing it, trying it, asking questions sometimes. And it's a free 18% of your overall grade. If you don't do it, the highest score you can get from the test is an 82%. Kind of like, here's your winning the lottery ticket. Here's all the numbers. Turn it in. Right. Look at that. Really not buy a soda. Oh, before I go on to this, homework being homework. We did, I will put it up. It's back, way back. In section 1.2, we eliminated the last 4 questions. You don't have to do those or turn them in, okay? 63, 65, 67, 73. For 1.4, I'm not going to test you on the last 5 homework questions. So you don't have to worry about doing 67, 71, 73, 75, 77 from 1.4. So you don't have to do those. And then from 1.7, you can eliminate or edit out 61 and 63. Okay. Not going to test you on it, so I'm going to take it off the home. I had to do a little BD. Okay. Any question about that? The review sheet. I did have a question. Does not need to be included with homework packet. The review sheet is not homework. And this is what I'm going to give this to you. I printed it. You're going to get it. This is the review sheet. Okay, just one review. Proposed. This is what your test looks like. It's not the same amount of questions, but this is what the questions will look like. You do not have to do any of it if you don't want to. You're not turning it in. The answers are right here. So I'm not going to have you turn something in when you have all the answers anyway. It's for you to prepare for the test. Your test will look just like this, so it's practice. So I don't know why anybody wouldn't choose to do it, but you don't turn it in at all. Not part of the homework. If you give me a second here, I'm going to set an alarm because I always make a big deal of I want to give you guys the review sheet, talk about it, and then I forget at the end of the class to hand up so hand them out. People are walking out the door and I go, wait a second. Don't move your legs. All right, so here's what you have to show to get the full credit. First thing, I want to see the rewrite. I want to see the expansion. I want to see what f plus g of x means. So I want to see this rewritten as f plus g of x is function f of x plus function g of x. Expand what that means. That's the first thing you should do. Practice it the way you need to do it with the easier questions. So when they become a little more challenging, did I take that one off? When they become a little more challenging, like you'll see, you can do A. Because now it's just substitution. Function f of x is 2x plus 5. So this is f of x. So I'm just using parentheses for right now to show the separation. It's that function f plus function g of x is this function x squared minus 9. Those two functions added together. Just because I see parentheses, I'm not going to multiply, it's addition. I put them in parentheses to show that this function is separate from that one. This is what f of x actually is. That's what g of x actually is. For addition, it's not necessary to put the parentheses because when you distribute a positive, the signs are not going to change. This is 2x plus 5 plus a positive x squared is still a positive x squared plus a negative 9 is still a negative 9. Where it does make a big, huge problem explaining that difference. We have subtraction. You need to put it in parentheses. Now the minor like terms, please do it in the right order. Start with the biggest power. It's just going to make your life easier. The biggest power, x to the first. These are the constants. These are x to the 0, x squared. So the biggest power is x squared. Then this is x to the first. There's only one term with x to the first, so 2x. And then a positive 5 minus 9 is negative 1. So f plus g of x is equal to x squared plus 2x minus 1. Any questions? Diagonal subtract. I need to see this. I don't want you to go straight to here. I want you to do this in every single time, no matter what. F minus g of x means function f of x minus function g of x. The function f of x is still 2x plus 5. And then minus function g of x is x squared minus 9. If you don't put parentheses, this has no chance of coming up with the right answer. Now, you might actually end up with the right answer because in your head, you're doing the subtraction, you're doing the distribution. In your head, you have the parentheses working, but your work does not justify the answer. And I'm going to take off points. The work has to justify the answer. How did you get there? Because this is not going to give you the right answer. There's no way. If you write this, there's no way to get there. Okay? It's this function f of x, this one, minus that function g of x as a whole. In the parentheses, order of operations, I can't do anything with 2x plus 5. And then x squared minus 9, there's nothing I can do in there. So I'm going to subtract it. When I subtract it, I'm going to distribute the negative. So it's now minus positive x squared, so it's negative x squared, minus negative 9, so that's now positive 9. When it was addition, addition doesn't change the sign. When you distribute addition, that's a positive x squared, it's still positive x squared. That was negative 9, it's still negative 9. If you don't put the parentheses, it's not going to hurt. However, putting the parentheses as a good habit isn't going to hurt, and it might help you remember to put it every time. So now, combining my terms, the biggest power for x, the biggest exponent is x squared. It's a negative x squared. And then we have a positive 2x to the first. And then positive 5 plus 9 is positive 14. So f minus g of x is negative x squared plus 2x minus plus 14. Question there. For a little more room, I'm gonna move C up a little bit. So C is F times G of X. Function F, rewrite it, is function F of X times function G of X. That's what this means. F times G of X means F of X times G of X. So you're going to take the F of X function, which is 2x plus 5, and because you're multiplying, parentheses, this is 2x plus 5, that's your F of X, times G of X. G of X is X squared minus 9. Parentheses. Since I'm multiplying these two together, they need to be in parentheses. And now we're just going to distribute or FOIL because it is a binomial times a binomial. Yeah. 2x times x squared. So 2 times x, 2x times x squared is 2x to the third. And then 2x times that negative 9. A positive times a negative going to be a negative. 2x times 9 is 18x. So that's the distribution, the first term times the other two terms. So this first term has multiplied with each term in the other parentheses. Now it's this term. We're going to multiply 5 times each one. That's a positive 5 times a positive x squared. Positive times positive, that's a positive 5x to the second. And then you have a positive times a negative. Positive 5 times negative 9 is negative 45. Clean it up. Simplify. The biggest power is x to the third. So we have 2 of those x to the third, 2x to the third. X squared. There's only one term with an x squared. It's a positive 5x squared. X to the first. The only term with an x to the first is this negative 18x. And then, minus 45. Last term. And that is F times G of X. And F times function G of the variable X. Any question there? F divided by G of X, the quotient. F over G of X. So we're just going to rewrite it. So that means it's function F of X divided by function G of X. Function F over function G of the variable X means take the function F of X as the numerator, 2x plus 5, divide by G of X as your denominator, x squared minus 9. If you can simplify, simplify. That's not going to simplify. It does not simplify. However, and this is good foreshadowing, or maybe in some cases, tales of doom ahead. Oh no. Please help. Domain. This question also wants domain. We want to know what values of X are allowed to go into that quotient. And we start by finding what we can't go or what we can't use. There's two bad things that might happen when you have a fraction. Sorry, I'm back. Getting ahead of myself. There's two bad things that will cause problems with the domain. Divided by zero or taking the square root of the negative. You see a square root. I don't have my glasses on and I don't see a square root either. Okay, I don't see anything. You are really blurry. Okay. When I tried to be an astronaut, minimum eyesight was 2200. If your eyes are worse than 2200, don't even bother. So I got my eyes checked before, and I was 2400. So yeah, I knew I wasn't going to qualify. But you still got to try. You never know. There are people like 2015. That means what you can see clearly. What a person with normal vision can see from 20 feet away, to them it looks like it's only 15 feet away. They have better than average eyesight. I've been wearing glasses since I was second grade. No square roots, but we have a denominator. So we have to figure out, is there a chance x squared minus 9 could equal 0? So you go over here and say, all right, let's find out. X squared minus 9 can equal 0. We haven't discussed how to solve something like this. It's actually in chapter 2. But this is college algebra. You have taken classes prior to this that technically you should know how to solve this. There's a couple of different ways you can solve this. The first way is factoring. When you have a polynomial like this, you should factor it and you let each factor equal 0. Now, if you recall, we did special products. I showed you that a plus b perfect square is equal to a squared plus 2ab plus b squared. And we talked about a minus b perfect square. B squared is just a squared and it's minus 2ab in the middle and then plus b squared. But then I kept telling you your best friend is going to be this one. If you have a plus b times a minus b, when you multiply that together, you're going to get a squared minus b squared. That's called the difference to the subtraction of two perfect squares. That's perfect square, see, a squared. That's perfect square, b squared, and you just have subtraction. If you have this, remember, equals means it works in both directions. If you multiply this together, you get this. If you have this, you can factor it apart and you get that. It's like saying 15 is equal to 3 times 5. Well, it goes both ways. 15 is 3 times 5, but that also means 3 times 5 can equal 15. It goes both ways. So I can take this apart and make it into this. That's what we have right here. That's a perfect square. X squared. 9 is 3 squared. This is x squared minus 3 squared. Difference of two perfect squares. And b squared minus b squared, then it's just a plus b times a minus b, because that's how we get a squared minus b squared. So the a is an x instead of a squared, it's x squared. So A is your X. Instead of B squared, you have 3 squared. B is your premium. So A squared minus B squared, A is your X, plus minus B squared is your 3 squared, so B is your 3. Factor. What can you do with that? Because we still don't have an answer yet. The zero product property. The zero product property. Yeah. A times B is equal to 0. If you multiply two things together and you get a 0, no matter what has to be true? If I multiply something together and I get 0, two things together, I get 0, what has to be true to make this work? 5 times what is 0? 0. Negative 72 times what is 0? 0. So if I have one number and I get 0, so if I have 87, what's the other number have to be to get 0? 0. So if A times B, don't know what they are. If A times B makes a 0, then what must be true? To make a 0, one of those, either A or B, has to be 0. If A times B equals 0, then A equals 0 or the B equals. One of them has to be the 0. That's the only way we won't get 0. So there's got to be 0. Only way to make 0 is you multiply by 0. So that means if this multiplies together and makes 0, then either x plus 3 is the 0 or the x minus 3 is the 0. Those are my two factors. Now we have something we can solve. Subtract 3. This x would be negative 3. Add 3. This x would be positive 3. It's 3 squared minus 9. 0. I get 9 minus 9. I get 0. I'm dividing by 0. Can I divide by 0? No. So that means the domain right now, x better not equal to 3. Well, what about this one? Substitute parentheses. What if I plug in parentheses negative 3 and then square it? Negative 3 squared and then minus 9. What's negative 3 squared? Positive 9 minus 9. So negative 3 makes 0 down here, doesn't it? So the domain x cannot equal negative 3 equal either. How do we find domains? We look for the troublemakers. We look for the ones that disrupt the denominator and make it 0 or negative in the radical for the square. The process, though, is you got to remember how to solve that when you do let it. Is there another way? Absolutely. I'm not going to give you one that went do this one. But since it was part of the homework, I'm showing you. This is like I said, it's a little, foreshadowing for chapter 2. Yeah, we're going to be doing factoring. So the domain. Now, as I was leafing through, separating the stacks of the quizzes and the ID numbers that are here, these ID numbers, I'm looking at the domain question. The domain question, you're supposed to write your answer using interval notation. Some of you just ignored it. If I would have only shown you maybe some quiz preps where I demonstrated how I did. Well, if only it was like open note where you could have had something to refer to so you could write it. Oh yeah, it was open. If only looking at more time so you could, it was take home. I'm sorry. On your test, you're going to get a review sheet. You're going to know exactly what to expect. But if you don't look at it or you try it or ask questions about it, if you don't prepare, okay. Those that fail to prepare are preparing to fail. Yeah. So, interval notation. If we did this in number line, there's 0. We have an open circle on -3 because we can't plug it in. Open circle on +3 because we can't use it. Everybody else is shaded. We can plug in any other number to the left of -3, in between -3 and 3, and to the right of 3. So it would be negative infinity all the way up to -3, parentheses. Join together, union, everything from -3 to 3 in between. Parentheses. Join together, union, everything from 3 to infinity. That's the domain of number 15, 14. Everybody but -3. Positive. But that's how you write it using interval notation. Because the domain, when you say, what is the domain? You don't tell them or tell me or write down what we cannot use. That's part of it. You have to tell us what we can use. What is in the domain? And that's how you do it. Okay. E. All right, now we can plug in some numbers. E minus F of -5. Have to show this first movie. Rewrite. So this is now function G of -5 minus function F of -5. G minus F of -5. We're going to plug -5 into the G function, minus plugging -5 into the F function. And as you do this problem, if you have to, again, recommending in your head, say it to your head out loud, or at least mumble it under your breath out loud, because you don't want to mess up the fact it's subtraction. So it's subtraction. So when I do write this out, parentheses, we're going to plug -5 into the G function. So when you plug it in, you're going to square it, -9. So it's going to do this. I'm going to square the -5. So parentheses around it. -5 is going to get squared, and then -9. And then minus f of -5. So that's 2 times x, so that's going to be 2 times -5. And then a plus sign. Take the extra time to show that step. Because now it's just order of operations. Substituted, now simplify. If you don't put parentheses, there's no way you're going to get the right answer. You may do the right answer, but I'll say your work doesn't justify it. If you go from here and you put positive 25, negative 5 squared without parentheses is not positive 25. I will take off a point. That is not positive 25. That is negative 25 if you don't have parentheses. X squared, so you got to square the whole thing. Now it's positive. So positive 25, and then minus 9 right there. And here we go minus. There we have negative 10, and a plus 5. 25 minus 9 is 16. We're done with that. Minus. We're still working this. What's negative 10 plus 5? Negative 5. So 16 minus negative 5 becomes 16 plus 5. Well, I'm not going to do it, but what I really should do is say no calculus at all. But I know that would just stress the heck out of everybody. So I'm not going to do that. But for a problem like that, you don't need a calculator. You just need to be able, you need to write it out and just do the arithmetic. H. F times G of a negative 12. You know, I'm going to say, first thing you got to do is rewrite it. So it's F of negative 12 times G of negative 12. Put negative 12 into the F function. So negative 12 goes in, so parentheses, 2 times negative 12 plus 5 times plug negative 12 into the G function. We're going to square it. So parentheses, negative 12 is going to get squared. And then we take away 9. And we're just doing order of operations now. Simplify the parentheses. 2 times negative 12 is negative 24 plus 5. Negative 12 squared is positive 144 minus 9. Negative 24 plus 5 is negative 19. 144 minus 9 is positive 135. And let's see. There's something negative. Negative 2,550. 2,550. Is that right?
Yeah.
We'll put it right. People mess up. They substitute a line, they get to here. They do this line, they get to here. Then they start trying to like distribute. They go for negative 24 times 147. Okay? What are you doing? Finish the order of operations. You could actually combine these together and get it to a 19. You know, combine those together and then just multiply those numbers. They're just numbers. So keep doing the order of operations. So my advice is really look at the review questions. The review questions are set up so you can be ready for the test. Look at this crazy thing. Don't panic. Don't panic. You read it. 3 times f of 3f plus 2g of 2. 3 times function f plus 2 times function g of a 2. 3f plus 2g of 2. Remember, these aren't variables. 3 times function f plus 2 times function g of a 2. So that means it's 3 times function f of 2 plus 2 times function g of 2. That's all it means. 3f means 3 times function f. 2g means 2 times the function g. So this would be 3 times. We plug 2 into the f function. We get 2 times 2 plus 5. And then we have 2 times. We plug 2 into the g function. 2 squared minus 9. And that's just a substitution. And now we simplify. So what should I do first? Distribute the 3 or finish the parentheses? Parentheses. 3 times. We got 4 plus 5. And this is going to be a 2 times. That's a 4 minus 9. This is 3 times. Don't distribute. It's just 3 times 9. Plus 2 times 4 minus 9 is negative 5. 27. Positive times a negative is a negative. 2 times 5, 10. 27 minus 10 is 17. Don't overthink it. Rewrite it. Rewrite it. And then substitute and simplify. I want you to do this step. Probably the most important step to do, because from here, now you know it's 3 times plug into. And you can see what to do next. But if you don't practice it, it's not going to magically happen. Numbers 20, 32, even. Let's see if we're ready for that. Yes, we can do that. So you get to pick 2. The 32. Um, five, four, 30, 30. What up? Five, four, 3, 28, 28, and 30. So F plus G of T minus 3. Thirty is F times G 3T squared. Rewrite it. F plus G of T minus 3. So function F of T minus 3 plus, we're adding in between, plus function G of T minus 3. So the first thing is, what does this mean? It means take function F and plug in T minus 3, and then you're going to add, take function G and plug in T minus 3. Add them together. So plug in T minus 3 into the F function. Whatever goes into the F function, you're going to square it and subtract 1. Now, I'm going to put it in a larger parentheses just because I want to keep function F of T minus 3 separate and make sure I finish doing that, simplifying all of it before I add it to G of T minus 3. So I'm going to work them on in their own parentheses. Okay, here we go. T minus 3 is going to get squared. So parentheses. T minus 3 is going to get squared and then minus what? That's F of T minus 3. Square it, minus 1. And then G. G is just replace X with T minus 3. So it's going to be T minus 3. There's the X. And then you're going to subtract 2 from that. And where it came from, the function F of X was X squared minus 1. And this is X minus 2. So I replaced the X with a T minus 3 and squared it. Minus 1. This was X minus 2, so X is now T minus 3. Right. Individual parentheses. What is this? What is that? We'll add them. In here, T minus 3 squared is T squared minus 6T plus 9. And then you have that minus 1. Plus, this is just T minus 3 minus 2. Remember how I'm going from here to here. I'm multiplying T minus 3 times itself, so I have to distribute. That's why there's something in the middle. That's how I'm getting that 6T in the middle. I'm using the special product that we covered last week or the week before. Still got to simplify. This parentheses, got T squared. Got negative 16. Now we have a 9 minus 1, so that's a plus 8. Over here we have a T. Negative 3 minus 2, that's a negative 5, minus 5. And I don't know if I mentioned earlier, you notice how when I use t as a variable, put a little hook to it? So you don't confuse it with pluses. T is an important variable that you're going to use all the time if you are a STEM major. So time you put a little hook to your t's. T squared. We have a negative 16 and a positive 1t. So negative 6 plus 1, negative 5t. And then 8 minus 5, positive 2. So f plus g of t minus 3. Is t squared minus 5t plus 2. Don't choose it. Well, rewrite it, substitute, simplify. Same steps every time. Same idea. Rewrite it. F times g of 3t squared. So it's going to be f of 3t squared. And we're going to multiply times g of 3t squared. That means plug 3t squared into the f function, plug 3t squared into the g function, and multiply those two things together. So we would put 3t squared into the f function. When I replace this x with a 3t squared, then I'm going to replace this x with a 3t squared. What am I going to do to this 3t squared when I replace the x with it? What am I going to do? Well, I'm going to use parentheses, but what will I do with it in terms of the function up here? What's going to happen to anything that goes in for x? You're going to square it. So when I replace this x with a 3t squared, I'm going to get that 3t squared has to get squared. F of x is x squared minus 1. So I have to square the 3t squared. That's my x squared and then a minus 1. Okay. All I did is replace in the f function, I replaced the x with a 3t squared. So since it used to be x squared, it's now that 3t squared that's going to be squared. Times. We're going to plug 3t squared into the g function. So that means whatever goes in, all you're going to do is take away 2. So it's going to be that 3t squared. And then you're just subtracting 2. So now rewrite it. First thing I did was I took this and I rewrote it into this. What does this mean? It means function f of 3t squared times function g of 3t. Then I substitute, just substitution. I replace for the f function, I replace the x's with 3t squareds. On the g function, I replace the x with a 3t squared. So that's just a substitution. Now I'm going to simplify order of operation. In this first parentheses, before I can multiply, I want to simplify this. 3t squared is 9t to the 4th minus 1. And the other one's already simplified. That's 3t squared minus 2. Really like this problem. You know why I like it so much? This little step right here. You know how I went from here to here? Rules of exponents. Yeah, first physical. Just rules of exponents. Are you okay with that 19 to the fourth? And it's only going to happen if you put the 3t squared in the parentheses. If you don't put it in the parentheses, you don't get this. Those are the two rules I did. 3t squared. Then I squared. So I have a product to a power, that's this one, a times b to the m, so I raise each one to that power. So 3t squared to the second, so I raise 3 to the second, and then I raise t squared. Going to raise that to the second, each one. 3 squared is 9. And then power to a power, you multiply the exponents. So power to a power, I multiply 2 times 2, there's my t to the 4. The exponents. Maybe I should have given you like a list of the rules of exponents. Maybe I should have posted it or something like that, or reviewed it or something. I don't know. Huh. I'm being an asshole. Sorry. Take it back. Now you have to multiply distribution. Distribute these two terms one at a time to each term over here. 9t to the 4 times 3t to the second is 27t to the 6. Positive times a negative is going to be a negative. 9t to the 4 times 2 is just negative 18t to the 4. So we're done with the 19 to the 4. Now we distribute negative 1. Negative 1 times 3t to the second is negative 3t to the second. And negative 1 times negative 2, positive 2. There's no like terms. That's the final answer. F times g of 3t squared. Is 27t to the 6 minus 18t to the 4. That is 4 with from this. (27t to the 6 minus 18t to the 4 minus 3t to the second plus 18. The whole time? Oh. Okay. If it's been off camera the whole time, you can always watch Thursday. Just go under Thursday, map 3A Thursday. It's labeled, and you watch their lecture. In case this thing has been offset. Okay. 28 and 30. The next part. Composition. Composite functions. So we have operations on functions: addition, subtraction, multiplication, division. And you recognize those operations. Recognize the plus sign, We recognize subtraction, we recognize multiplication, we recognize what is division, and division is written as a fraction. So we have two functions. We have f of x is equal to x squared. G of x is equal to x plus 1. Okay? We are going to do this. Composition of functions, a composite function. This is actually pronounced f, function f, circle, function g. Function f, circle, function g of the variable x. F, circle function, f, circle g of x. That's the notation. What it means, here's the translation, here's the rewrite, here's what you want to do. F circle G of x means from left to right, you have F of, and inside you have G of x. You are going to plug G into the F function. This is where we plug one function into another function. Composition. We're going to compose them. A composite. A composite of two functions. It's about rewriting it. And it's always from left to right. So when I see F circle G of x, and over there we're going to do G circle F. The first one is on the outside, F of, and then inside is G of, and then there's your variable. Now, order of operations, you should do what's first? What first? What's the P standpoint? Do the parentheses first. So you're going to work on the inside. You always do what's inside first. We're going to plug whatever G of x equals into the F function. So you got to start with what this is. So, all right, G of x, what the heck are you? Oh, you're x plus 1. Because that's what you are. So now you're going to replace this with an x plus 1. This is just F of x plus 1. You start on the inside. The inner function goes first. What am I going to plug into the F function? G of x. Well, what the heck is G of x? Oh, it's over here. G of x is x plus 1. So now this is not G of x plus 1. So now I have actually something I can actually do. I plug x plus 1 into the F function. Basically, F it. Now that you know what G is, you're going to put that in here. We're going to replace that with an x plus 1. So F of x plus 1, whatever goes in, you will square. And that's x squared plus 2x plus 1. So F circle G of x is x squared plus 2x plus 1. It's about it's about rewriting it first and then substitution, simplify. Rewrite, substitute, simplify. Change the order will change the outcome. Unless there's something special about it that we'll learn in 1.7. The outer function from left to right, the one on the outer is G. And then from left to right, G of F and F of X. I want to take G of something. Well, G of what? Inside the G is F of X. So I have to figure out what F of X is first. What the heck is F of X? Oh, here it is. F of X is X squared. Because that's what you're given. F of X is given as X squared. So G of F of X, this substitute is now G of X squared. And now we're just going to put X squared into the G function. Well, whatever goes into G, all you're going to do is add 1 to it. Whatever goes in, we add 1. So G of X squared is just that X squared, and we add 1. So G, circle F of X is X squared plus 1. That's the composition of G and F as a function. That is F plugged into G. That's what it looks like. And G plugged into F, this is X squared plus 2X plus 1. One into the other. Substitution, simplify. Rewrite it first, because otherwise you won't know who's going into what. You're just making it up. Okay? Rewrite it, substitute, simplify. So we're doing 41. We're going to come down here and do 6 and 3. Here we get 68. The pictures. There's 3 questions, A, B, and C on 41. A, they want you to define F circle G, and what they really should have done is to put what is F circle G out of X. And then for B, they want G circle F. That was. And then, if possible, what is F circle G of 0? So actually plug in a number. So 41, F of X is 2X squared. And G of X is X plus 4.
Rewrite from left to right. The outer function is F. Inside the function F, the next one over is G. Inside the G is the variable X. F circle G of X is F of, and inside F is G of X. And you start on the inside. What is G of X? Oh, G of X is X plus 4. G of X is X plus, that's all you know. So we're going to rewrite this as F of X plus 4. You do what's inside first, you got to figure this out. So it's F of, we now know that the inside is an X plus 4. I'll put X plus 4 into the F function. Whatever goes in, it's 2 times whatever X is squared. So that F of X plus 4 is equal to 2 times that X plus 4 squared. 2x squared becomes 2 times X plus 4 squared. So now that's simplified.
Order of operations, what do I have to do first? For parentheses, X plus 4, there's nothing I can do inside. So inside the parentheses is done. So what do I have to do next? Exponent.
I can't multiply by 2 unless I do this exponent first. So it's F of X plus 4 is equal to this 2 times X squared plus 8X plus 16.
Remember, you got to multiply it out.
It's X plus 4 times X plus 4. That's no problem. And now we can just distribute the 2. So F of X plus 4, 2x squared plus 16x plus 32. So F circle G of X is equal to 2x squared plus 16x plus 32. B, I'm going to do it over here. B circle F. So rewrite. Who's on the outside? Left to right. What is the outer function? G, and then inside that is F of X. Now we start on the inside, we need to know what F of X is. So it's going to be F of X is 2x squared. F of X is 2x squared. So we're going to replace that with 2x squared. And now I have G of 2x squared. What happens to anything going into the G function? What do? We just add 4. Whatever goes in, we just add 4. So if I replace, X with a 2x squared, all we're gonna do is 2x squared, and then we're gonna add 4. And that's it. Because you can't go any further. And then part C. What is F circle G of 0 if possible? And that if possible means what, as long as you don't get 0 in the denominator. Understand, you can do this real simple. It's F of G of 0. So in order to do, because we haven't done a problem with actual numbers yet. I want to plug something into the F function. The outer function is F. I'm going to plug something into this F function. What am I plugging in? Whatever's inside. I have to start on the inside. I'm starting with G of 0. I want to figure out what G of 0 equals first. If I'm going to plug something into the F function, I got to start inside G of 0. So we do G of 0. G of 0 is 0 plus 4. What is 0 plus 4? 0 plus 4? 4. So now we rewrite it, we substitute, we get F of, instead of G of 0, that's F of now 4. And now we just plug 4 into the F function. Whatever goes into the F function, it's 2 times x squared. So this is going to be 2 times that 4 squared. Two times 4 squared is 16. And what's 2 times 16? 32. So F circle G of 0, final answer is just 32. What about here? What if I had like plug in 15 different numbers? 0, 1, 2, 3, 4, 5, 6, a whole bunch of numbers. I actually have the function for any value of x. I could have done F, because we did it first, of the 0 here. 2 times 0 squared plus 16 times 0 plus 32. What is 0 squared? What is 0 squared? 0. What's 2 times 0? Good. What's 16 times 0? Plus 32. What is 0 plus 0 plus 32? It better be the same answer. But here's the thing. If all you wanted to know is what is F circle G of 0, and we didn't care what F circle G of x was, you don't need to do this and then plug in 0. Just do that. If all you're asked is what's this one number, you don't need this. Just plug the number and do that to it. So make sure you understand, when you do 61, 63, you're only doing part A, part B. 61A, 61, 63A, 62. You don't have to do part C. This is 63. We want f of g of x, g circle f of x, and are they equal to each other? That's all. Find one, find the other, and are they equal? You know what? I'd rather do the multiplication. So if you need to see that, we do that. Rather do the multiplication. Actually, that's not. So we want to do 68 and 70. We have two pictures. We have a picture of F, we have a picture of G. Two separate graphs. Over here on the left is F. On the right is the picture of G. F minus G of 1. F times D. Rewrite. F of 1 minus G of 1. The ones are the ones, because we're looking at a graph now. The ones are the with respect to a graph. What do we plug into a function? They're the x's. These are ordered pairs. We plug in 1. This is the f function. This is the g function. We plug in 1. So on the f function, when you plug in 1, this is 1, 2 on f. F of 1 is equal to 2 minus, on the g function, when you plug in 1, we're up there at 1, 3. G of 1 is equal to 3. So it's just 2 minus 3, which is -1. But you need to understand what this means in the first place. Rewrite it. F minus G of 1 is F of 1 minus G of 1. What does that mean? Plug 1 into the F function. Where do I get that? It's the y coordinate. Look on the graph of F. X is 1. What's the y? Y is a 2. Plug 1 to the G function. Look at the G graph. When 1 goes in, the y coordinate's a 3. So it's just 2 minus 3. So here, this would be F of 4 times G of 4. So the ordered pair for F, we're looking for F of 4. So right here, F of 4 is this ordered pair. We have 4, 4. So F of 4 is 4. 4 times G of 4. When 4 goes into the G function, what's that ordered pair? 0. G of 4 is 0. So F of 4 times G of 4, G of 4 is 0. 4 times 0. Anybody in song? No? Still the line. Don't leave, because I want to do, we're gonna do 68. I was like 70. So take one. Now pick up the extras back. It's all the rewrite though. This means f of 1 minus g of 1, and then find the y coordinate. So same thing with number 70. Rewrite it. Substitute. Simplify. 70. F circle G of 1, and B is G circle F of 3. This, because it's a composite function. The outer function is F. What is inside the F function? What's in here? G of what? G of 1. So the first thing you have to figure out is what does G of 1 equal? So we go over to the G function. In the picture, G of 1. So when X is 1, what's that Y coordinate? So G of 1 is a 3. 3. And now, once you know what you're looking for, this is now just F of 3. So now we go to the F function. And we're going to look 3 into the F function. When 3 goes in, what's the Y coordinate? 2. F of 3 is equal to 2. So F circle G of 1, 2. It's like you're trying to put together IKEA furniture. You got to read the instructions. You got to follow the map. There's no words on it. You're just looking through the order of bearers. But you got to keep track of where you're at. And it's rewriting it that tells you what you're looking for first. So when you rewrite this one, on the outside is G, and inside the G function is F. And what are we plugging into the F to start with? F of what? F of 3. And, well, right here, we already figured out what F of 3 was. Right? F of 3, 3 goes in, we get 2. You just can't. So this is a 2. So now it's just G of 2. So we go over to the G function. And here's 2. And if we plug 2 into the G function, what's the Y coordinate that comes out? So G of 2 is 2. So G circle F of 3. 2. It's not a trick. Rewrite it, who's in what? Because when you get to this question on the review versus when you see it on the test, the key to doing it correctly, number 21. You got F, you got G. What is G? Circle F, circle G, circle F, circle G, circle F, circle G. Okay, the thing. I'll give you a hint. It's going to be a bonus type. And if you just find a pattern, maybe you don't have to do the whole thing. But if you don't actually try it for yourself, you'll just be whatever. Give it a try. All right, see you Monday. You have enough to get all of 1.6 done. And you should be able to do all of the routines except for the last level, except 24. G on F of three, I'm gonna different. When I plug in three. That's what we do. So now this becomes G of two. So over here, when two goes in, so now it's the G of two. So the answer to that is. Because it's asking for G of F of three. I had to figure out what F of three was first. F of three is two. So now I'm gonna plug, so when I rewrite it, when I rewrote it, I rewrote it. When I rewrote this, it's G of F of three. So I figured this out first. When I plug three into F, we get two. Okay, because of that order. So now this is G of two. Now I know what I'm plugging into the G function. I'm plugging two into G. So now I can go over here to the G picture. When two goes in, the Y value is a two. So G of two. Okay. What is this equal? It equals two. So now what is G of two equal? When two goes in for X, Y is equal to that two. If this came out in students, if I asked let's see, if it was F of two, okay, F of two is zero. Because when I plug in two, it's zero. So now this would be G of zero. Because right here, for G, when X is zero, the Y value is 4. So when I put 0 into G, the answer would be 1. Yes. 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 I didn't check. No, I have a long weekend.
When this like some of like the class like from the YouTube.
And if the camera wasn't focused on it, because it didn't look like I didn't move it for a while. Well, shoot, I'll tomorrow.
Okay.
Thank you.